Hello friends, I am Neha and once again I welcome you back to our YouTube channel about technology. In this video tutorial, we'll be discussing an important problem related to operating system, that is, critical section problem. Well, a computer has multiple processes that need to access shared resources simultaneously. And while accessing these resources, processes must cooperate with each other in order to avoid any kind of error. So, this is the situation where critical section plays an important role. Let's get into more detail about critical section problem and its solution. Now what is critical section? As we know, a computer has multiple processes that need to access shared resources simultaneously. For example, modifying a common variable, update a database table, writing to a file, accessing peripheral devices such as printer, memory, display, etc. For this, each process has a section where the code for accessing shared resources is written. We refer this section as critical section. While accessing the shared resources, the processes may produce inconsistent data. To avoid this inconsistency, the process accessing shared data must cooperate with each other. For this, when a process is executing in its critical section, no other processes should be allowed to enter in its critical section. Let us understand this with the help of an example. So, we have two processes, process P0 and process P1. If you can notice, both the processes are sharing a common variable a where a is equals to 0, and both the processes are incrementing the value of variable a by 1. We will discuss two scenarios here. In case 1, P0 starts execution first and reads the value of a, that is equals to 0. It further increments the value of a by 1. So now the value of a is equals to 1. Next, P1 starts execution and reads the value of a, that is equals to 1. It further increments the value of a by 1. So now a is equals to 2. After both the processes completes their execution, the value of variable a comes out to be 2. Now, let us discuss the second scenario, where P0 starts execution first and reads the value of a, that is equals to 0. Suddenly, context switching takes place and P1 takes over the charge and starts execution. P1 reads the value of a, that is equals to 0, and increments the value of a by 1. As P1 has completed its execution, it gives charge back to process P0. Now, process P0 has already read the value of a, that is equals to 0. It would now increment the value of a by 1. In this case, lastly the value of a is equals to 1, which is different from the value of a in case 1, that is equals to 2. This scenario where sequence of execution affects the result is called race condition. This is why a process needs to access the shared resources under its critical section. Knowing why we require critical section, let us see how to implement it. The critical section of a process must be designed in such a way that a process must first request to enter its critical section. If the permission is granted, then it can execute the critical section, and then there must be a way to exit the critical section, and rest would be the remainder section. The implemented critical section must satisfy some properties. First is mutual exclusion. It means at a time only one process must enter its critical section. Next is progress. It means if a process doesn't want to enter its critical section, then it must not restrict other processes from doing so. The last is bounded waiting time. It means there must be a bounded time that a process must wait to enter its critical section. Although a critical section takes a short duration, so every process gets a fair chance of entering the critical section within a finite amount of time. Now let us figure out some solutions to critical section problem. Let's say we have two processes, process P0 and process P1, that are accessing the common shared resources, and they have their corresponding code to enter the critical section. Initially, let the value of turn is equals to 0. Now, the process P0 tries to enter its critical section. It executes while 1 and further checks for the condition while turn not equal to 0, which turns out to be false. So, it exits the while loop and enter the critical section. On exit, it makes turn equals to 1 and execute the remainder section. Similarly, P1 checks for while 1 and enter the while loop and checks for condition while turn not equal to 1, which turns out to be false. So P1 exit the while loop and enter its critical section, and then on return it makes turn equals to 0. It executes its remainder section and exit. If you can observe one thing, every time P0 wants to enter its critical section, it needs the value of turn to be equal to 0. Similarly, every time when P1 wants to enter its critical section, it needs the value of turn to be equal to 1. So, even if P0 after executing its critical section immediately want to re-enter its critical section again, it has to wait for P1 to make the value of turn equal to 0. Here, though we have achieved mutual exclusion, but we have not achieved progress, as if P1 doesn't want to enter its critical section, it will block P0 to enter its critical section. Now let us consider the second solution, where we have a flag array. Initially the flag of 0 and flag of 1 both are false. Now P0 started execution and check while of 1, which is true, so it enters the loop and make flag of 0 equals to true. Now P0 checks while flag of 1 to see whether P1 is in its critical section or not, which comes out to be false, so it exits the loop and enters its critical section, and on exit it makes flag of 0 equals to false. Now P1 starts execution and check while of 1, which is true, so it enters the loop and make flag of 1 equals to true, which confirms that P1 want to enter its critical section. Further, it checks while flag of 0 to check whether P0 is in its critical section or not, which is false, as on exit P0 had made flag of 0 equals to false. So it exits the while loop and enter the critical section, and on exit it makes flag of 1 equals to false. If you can observe one thing, every time P0 or P1 want to re-enter its critical section immediately after execution, it needs a value of flag 0 and flag 1 to be false, which is possible as every time P0 or P1 executes, it turns the value of flag 0 and flag 1 equals to false correspondingly at the end of their execution. So here we have achieved mutual exclusion plus progression. Consider the case when P0 had just confirmed that it want to enter the critical section by making flag of 0 equals to true, and just at that moment the context switch happens and P1 gets the charge and it starts executing. It makes flag of 1 equals to true and further checks for while flag of 0, which is true now. It will get blocked in the loop and it will also block P0. So this solution doesn't satisfy bounded waiting time property for critical section problem. Let us consider our third solution, where we have implemented both flag array and the turn variable. Flag of 0 and flag of 1 both are false and the value of variable turn is equals to 0. Starting with P0, it enters while 1 and makes flag of 0 equals to true and turn equals to 1. To confirm that it wants to enter the critical section. Further, it checks the while loop, which turns out to be false, as flag of 1 is equals to false. So P0 enters the critical section and on exit it makes flag of 0 equals to false. Now P1 starts execution and checks while 1 and enter the loop. Here it makes flag of 1 equals to true and turn equals to 0. Further, it checks the while loop, which turns out to be false, as flag of 0 is equals to false. So P1 enter the critical section and on exit it makes flag of 1 equals to false. Here, even if context switch happens, the process would not get into deadlock as in previous case. This solution is called Peterson's solution. So this is how critical section is implemented in the processes to avoid inconsistency. For more details, you can refer our official website binaryterms.com. I had provided URL for the same in the description below. Please like and share our video with your friends and family, and don't forget to subscribe our YouTube channel about technology. Keep checking the channel for further updates and put your comment and queries in the section below. We'll be back again soon with a new video. Till then, take a good care of yourself.